Hello friend, welcome back to channel. I am Ram. In today's video, our continued journey with machine learning project. This is a part 2 where I am going to train the models. We'll do the predictions and also we'll do the model evaluations, and then we'll choose the best model. So before starting this video, if you are new to the channel, please do not forget to like and subscribe. First step, what I'm going to do, I'm going to import the multiples library. Since this problem is a regression problem statement, so I'm going to only import the regression models. So the first model is a linear regression, second is a random forest regressor, third is a support vectors regressor, AdaBoost regressor, reach, lasso, decision tree regressor, catboost regressor, XGBoost regressor, and gradient descent regressor. Second step, I need to initialize the models. Then third, I need to train the models. And then fourth, I'll do the predictions with training dataset and testing dataset. And fifth, we need to evaluate the models. The performance matrix I have taken already here, the mean absolute error, mean square error, and root mean square, and R2 scores. With help of this matrix, we will be evaluate the models. And then finally, we need to choose the best model. So now let's get started. So the first step, what I'm going to do, I'm going to import the multiples library from the scikit-learn. Importing models from importing model from scikit-learn. Yeah, importing library for model training. So the first model is nothing. The first model, the linear regressor. So from scikit-learn, I'm importing all the model from the scikit-learn. From scikit-learn's dot linear models import, which is the linear regressor. Okay, and then second I have also the reach. Then third is lasso. And then I need to also import the decision tree. Import decision tree regressor. And then scikit-learn, I need to import the ensemble technique. Ensemble technique basically is the random forest regressor, gradient descent regressor, and then AdaBoost regressor. Okay, then I need to also import the support vector machine from scikit-learn. Support vector machine import SVR means is support vector regressor from scikit-learn. And then I need to also import the catboost. Import catboost regressor. Then XGBoost is also I want XGBoost. Import XGBoost regressor. So how many model I have imported? The 1 2 3 4 5 6 7 8 9 10. 10 is enough. Then I need also then the second step, what I need to do, I need to initialize all the models. So in order to initialize the model, so the model so in order to initialize the multiples model, I am giving the model equal to, and I am passing the list. And then the first model is a linear regressor and with respect to linear regressor this, and then I need also the reach, and the reach is this, and then third is I need lasso, and with respect to lasso is lasso, And then finally what I need also random forest regressor, and with respect to random forest is the random forest regressor. And then what I need, decision tree regressor, and with respect to decision tree is decision tree regressor. Then I need the AdaBoost regressor and AdaBoost regressor. Then I need gradient descent regressor, and with respect to gradient descent is the gradient descent. Then what I need also the cat boost regressor, and then the cat boost is the cat boost regressors. Then finally what I need a XGBoost regressor. Then I need a 1 2 3 6 7 8 9. Then which one is missing over there? Support vector machine and SBR. Okay, first step, I have imported the library for the model training, and second, I have also initialized the models, and third, I need to train the models. Okay, yeah, I can write here the model training. So the first I want one model list, and I want also R2 score train score. Okay, and I also want R2 test score. Model list means whatever model I am going to train, I would like to append to the model list, and same the R2 train score and R2 test score. So now with help of the loop, I am going to train the model. Now let's see the magic. For I in range of length of list of model with respect to model equal to what I want, and list of model of value with respect to I, then model X train and Y train. Now we train the model. The next step, we need to do the predictions with training dataset and testing dataset. Prediction with training and testing data set. So my training data set is a Y train pred equal to model dot predict with respect to X train. Y test pred equal to model dot predict with respect to X test. Alright, the next step, we need to evaluate the model with training and testing dataset. So in this particular case, I am going to evaluate the model with help of performance matrix, where we have already imported the four matrix. The four matrix, which is nothing. The first matrix here, the ME, which is stand for mean absolute error, MSE, which is stand for mean square error, RMSE, which is stand for root mean square, and R2 score. So now let's evaluate the models. Evaluate the model with training and testing data set. Then my first is a mean absolute error. Okay, white train, mean square error, white train, root mean square, white train, and then white train I need a R2 score with respect to evaluate matrix, which is nothing. The evaluate, I am going to evaluate the model with respect to white train print, and with respect to white train. And then the same I need to do also with respect to testing data set. White test, mean absolute error, sorry, white test, mean square error, white test, and then root mean square, and then white test R2 score. And with respect to evaluate, come on, where is this? And then this is a white test breed, and white test. Now let's see. Okay, we also evaluate the model, and then what I need to do, I need to append all the model to the model list. So model list dot append with respect to list of model of key of I. This is also done now. And then next step, we need to check the performance of the model with training dataset and testing dataset. So model performance with training and testing dataset. Okay, so before I need also the model name. Okay, and here I write the model name, and with respect to whatever the model is, this. Now print, and here I can write here the model performance with training dataset. Absolute error, and with respect to this I would like to print, and then format of the first matrix is the, I like to the white train mean absolute error, and second matrix is I would like to pass mean square error, and with respect to mean square errors dot format, and then white train mean square error. Then third matrix is root mean square, RMSE with respect to then format with respect to white train RMSE. Then finally I need R2 score. So the first format with respect to white train R2 score. Alright, and then the same things we have to also do with respect to testing. Print model performance with testing dataset. Print. So the first model is nothing, the mean absolute error format, which is RY test mean absolute error. Print mean square error, and then for F, I think this is, and then format with respect to Y test mean square error, and then the next finally is the root mean squares. Root mean square with respect to 4 and F, and then format with respect to Y test RMSE. Alright, and then finally is I would like to also train the R2 score. R2 score. Format with respect to Y2 R2 score, and then I need to also append the R2 training score and testing score. So R2 training score dot append. So I am going to only append this particular, this is the R2 score, Y train R2 score. So R2 train score with respect to Y train R2 score. Okay, and then same we need to also do with respect to testing score append with respect to Y test R2 score. Alright, then done already. Print, I need to do multiply t and then print is less than, it will work well. Okay, fine. I need to do some fancy work here. And finally the model has been trained, and second we also did the predictions, and then we also did the evaluate the models with training and testing dataset, and then with respect to the performance of the model. So the first model, which is the nothing, the linear regressor. This is a ME stand for the mean absolute error, where the accuracy is a 4.27, mean square errors, which is the accuracy is 28%, 85%. These are with respect to the training data set, and with respect to testing is also there. See the the mean absolute error is 4% and mean square error is 29%. RMSE is 5% and R2 score is 86%. So in this particular case, what I am going to do, I am going to make the one data param, and with the help of this data param, I can only able to extract the best model. So now let's create the data param. PD dot data frame list of GIF with respect to model list should be there, and R2 test, I like to give the first train and R2 test score. So the model is here. I'd like to make the one column, 3 columns should be there. So first is the model name, come on. Second is the R2 train score, R2 train score, and then R2 test score. Okay, then dot sort the value with respect to value. Okay, so value is by what I want, R2 score, R2 test score, then by ascending parameter is a false. Now let's see, this is a super important. Now this is the final step. What I'm going to do, I'm going to choose the best model from this particular model list. So in this particular model list, there are only the 2 models which model are generalized. Why I'm telling the generalized? Because see, for the example is the linear regression. With respect to training is a 85% accuracy, and with respect to testing is 86% accuracy. And for the reach is also, with training is 85% accuracy and with testing is 86% accuracy. That means model train well with training dataset and also with testing dataset. This is a generalized. And there are also some model are overfit and underfit. Overfit means where the model perform well with the training dataset and it's failed to perform with the testing dataset. For the example, gradient descent. With training is 89% accuracy and with testing is 84% accuracy. We cannot say the model is a overfit, but still I can say this model is a overfit. Second, random forest regression. With training is 97% accuracy and with respect to testing is 82% accuracy. That means model perform well with the training dataset and it's failed to perform with the testing dataset. Second, I can say there is also the cat boost regression. With training is 95% accuracy and with testing is 81% accuracy. This is also model is a overfit. AdaBoost is also generalized model, but with respect to accuracy is low. XGBoost with training is 99% accuracy and with respect to testing is 77%. That means this model is also overfit. Decision tree regressor with training is 99% accuracy and with respect to testing is 71% accuracy. This model is also overfit. And the lasso and then support vector machine, these are 2 models are underfit because the model failed to perform with the training dataset and also failed to perform with the testing dataset. In this particular scenario, I can say the high bias and high variance, these are 2 models are underfit, and this is the 5 and there are also the 5 model. These model are overfit. In order to choose the best model, I will make this one is a green. So these are 2 models are generalized model. The first is a linear regressor and second is ridge. Alright, and then I'll to choose the blue, and then I am going to highlight this particular model, which one is overfit. The gradient descent, random forest, cat boost, these 3 models, and then XGBoost is also, and then decision tree. These are 5 models are overfit. Because why? The model perform well with the training dataset, but it's failed to perform with the testing dataset. That's the scenario we can say these are models are overfit. I don't know why not working my pen. Overfit model. Alright. and then this model is generalized model, and then finally we have another model which is underfit. Underfit condition, that means my model failed to perform with the training dataset and also with testing dataset. That means is the high bias and high variance. I would like to choose the color. This color I am going to choose this one. Okay. I don't know why not working. Come on. In this condition is a underfit. High bias and high variance. Another condition is a underfit, where I can say the low bias and high variance. And this one, which is a generalized model to linear regression and ridge, we can say low bias and low variance. So in short, from these 10 models, we found only the 2 models which are generalized model. The first model, which is a linear regressor, or second is ridge. So we can train this model. And we have also another option in order to boost the model accuracy. How we can able to boost the model accuracy? With help of hyperparameter tunings. And the next video, what I'm going to do, I'm going to apply the hyperparameter tuning, and with help of the hyperparameter tunings, I will try to increase the model accuracy, and then we'll do the same things. We'll do the training, we'll do the predictions, we'll do the evaluations, and then we'll choose the best model. So guys, that's all for the today. If you found this video is helpful, please do not forget to like and subscribe my channel. Thank you so much. Bye bye.